Now that we talked about network models, let's make another big networking topic feel simple. In this lesson, we're going to talk about frames, packets, and addressing. And really, all three connect to one big idea. When data moves across a network, it cannot just fly around with no structure. It has to be packaged, labeled, and sent to the right place. That is what this lesson is really about. By the end of this lecture, I want these terms to feel much more familiar, much less intimidating, and much easier to picture in your head. A helpful way to think about networking is to compare it to shipping a package. If you want to mail a gift to someone, you do not just toss the item into the street and hope it somehow arrives. You put it in a box, you add the destination, you hand it to the delivery system, and that system moves it step by step until it reaches the right person. Networking works in a very similar way. Data also needs packaging. Data also needs labels. And data also needs a system that knows how to move it from one place to another. That is why this lesson matters so much. Let's start with one very important word: encapsulation. Encapsulation simply means wrapping data with extra information so the network can move it correctly. That extra information can include things like where the data came from, where the data is going, and what service should handle it when it arrives. So, in beginner friendly language, encapsulation means take the data, put useful instructions around it, and make it ready for travel. That is a big part of what networking devices and software are doing behind the scenes. Now, let's clear up three words students mix up all the time: frame, packet, and segment. The easiest way to understand them is to think about what level the data is moving at. A frame is data prepared to move from one physical interface to another physical interface. A packet is data prepared to move from one host to another host. A segment is data prepared to move from one application to another application. So these are not three unrelated things. They are three ways of talking about data at different parts of the trip. And yes, in the real world, people often casually say packet for almost anything. But technically, these words do have different meanings. Here's a simple way to picture it. Imagine a message starts inside an app. At that point, the communication is really about one app talking to another app. So you can think about the data as a segment. Then the device prepares that data to move across the network. Now we talk about it as a packet. Then the local network connection prepares it for the actual nearby delivery step. And now we talk about it as a frame. So, some easy memory trick is this: application level, then device level, then local connection level. You do not have to memorize every tiny detail today. What matters most is understanding that the data gets wrapped in layers so it can travel correctly. Now, let's talk about addressing. Addressing is how the network knows who should receive the data and where that data should go. Without addressing, the network would have no idea where to deliver anything. It would be like mailing a package with no name, no street address, and no destination. So every time devices communicate, some kind of addressing has to be involved. That is what gives the data direction. It tells the network this came from here and it needs to go there. At the beginner level, there are three address types you really want to know: a physical address, an IP address, and a port number. These three work together. The physical address helps with the local delivery. The IP address helps identify the device or interface across the network. And the port number helps identify which application should receive the data once it gets to the correct device. So, data is not just trying to find this right computer, it's also trying to find the right place inside that computer. A physical address is often called a MAC address. You may also hear it called a Layer 2 address. This address is associated with a physical or virtual network interface. In simple terms, this is the address used for local delivery on a nearby network segment. So if devices are talking on the same local connection, the physical address helps one device identify the correct destination on that local network. That is why switches care about MAC addresses so much. An IP address is different. This is described as logical interface address. You may also hear it called an interface address, host address, or layer 3 address. In simple terms, the IP address helps identify where a device or interface exists in the bigger network. So while a MAC address helps with the local step, the IP address helps with the broader trip. That is why routers pay attention to IP address. Routers are trying to move data across networks, not just across one local cable or one Wi Fi segment. A really common beginner question is, why do we need both a MAC address and an IP address? Why not just use one? Because they do different jobs. The physical address or MAC address identifies the interface for the local connection step. The IP address identifies where that device or interface fits in the larger network path. A simple way to say it is this: the MAC address helps on this local network link, and the IP address helps on this network and beyond. So one is more local, one is more topological. That is why both are useful and why networking uses both at the same time. Now let's go one step deeper. Even after data reaches the correct device, that device still needs to know which application should receive it. That is where the port number comes in. A port identifies an individual application or service running on the host. So think of it like this: the IP address gets the data to the right device. The port number helps get the data to the right app on that device. That is why ports matter. They help make sure the data reaches the correct destination inside the computer, not just the correct computer. So let's put the whole picture together. Imagine one app on your laptop wants to send data to an app on another device. First, the application creates the data. Then the data is encapsulated with information about the apps involved, such as source and destination ports. Then the host adds information about the source and destination devices or interfaces, such as IP addresses. Then the local interface adds information for the local delivery step, such as the physical source and destination addresses. So as the data moves, more useful labels get added to help each part of the network do its job. That is why networking feels layered. Different parts of the system need different kinds of information. Another beginner question is, how does a device know the local hardware address of the other device? On an IP version 4 network, that matching process is done using ARP, the Address Resolution Protocol. On an IP version 6 network, that job is handled by neighbor discovery. You do not need to master every step of these processes yet. At this stage, the big idea is simply this: devices need a way to match network address to the local hardware address so the data can actually be delivered on the local segment. Let's clear up a few beginner misconceptions. First, a packet is not just the internet thing. It is a specific way of talking about data moving from host to host. Second, a MAC address and an IP address are not the same thing. They work together, but they are used differently. Third, a port number is not the same as a physical port on the outside of a device. In this lesson, a port number means an identifier for an application or service. And finally, networking is not random. Data gets wrapped, labeled, and moved in a very organized way. This lesson matters because these terms show up everywhere in networking. If you understand frame, packet, MAC address, IP address, and port, then later topics become much easier. Switching makes more sense, routing makes more sense, troubleshooting makes more sense, and even protocol discussions become easier to follow because now you are starting to see what the network is really doing when data moves from one device to another. So let's wrap this up. A frame is used for local interface to interface delivery. A packet is used for host to host delivery. A segment is used for application to application delivery. A MAC address helps identify the right interface on the local network. An IP address helps identify the right device or interface across the network. And a port number helps identify the right application on that device. When you understand those ideas, networking starts to feel much less mysterious. Instead of seeing random technical terms, you start to see a system. Data gets packaged, labeled, moved, and delivered. And that is how devices identify each other and exchange data across a network.